Hey, welcome back. I hope you're all well. This is part 2 of the Pioneer QX-747 restoration or rejuvenation, or whatever you want to call it. Can't recognize it, of course, because the face is gone, and trying to work on removing buttons to clean and stuff like that. But so yeah, this is part 2. If you missed part 1, go back and watch it. It was last week. I'm hoping to get these in all back to back, these videos, so that it makes sense to people. But yeah, this is a recapper's dream. I've been going through this thing for the last few days, recapping. Just to give you a sense of, I'm not even done yet. I still have lots to do. But here's a look at the capacitors I've changed out so far. I'm going after pretty much everything, because pretty much everything is reading out of tolerance, or they're just getting old. So yeah, the other day I recapped these two boards. They're ready to go back together. These are the 4-channel matrix boards, so those are done. Haven't touched the power amplifier yet. Haven't touched the tuner. Okay, so there's still lots to do on this. One thing I wanted to do today is I'm going to recap the 4-channel decoder. And I did the phono equalization amp the other day. I did that yesterday, I believe, or the day before. And that's done. The two tone control boards are done. The power supply is done. The protection circuit's done. So I'm working my way through this. I still have to re-clean this relay because I was disappointed with the results after my last cleaning. So we're going to go through that again. Yeah, I still need to get the switch assembly out and get that. Something we can do right now is pilot lamps. So I have removed a couple screws here. I'm just going to remove these guards for the dial string. And I'll take out this other screw. Okay, so that screws out. And this should come out from the back. This just kind of protects the lamp cord here from getting tangled up with everything else, and gives it a nice surface to slide on, so it's low friction. And then we have our lamp board here. It's got I believe it's 1, 2, 3, 4, 5 of the fuse style lamps. So let's take this out. And it's also got all the connectors for the indicator lamps, what mode it's in. Okay, so we got this out. This is going to have to stay out of the way. We can just peel this back like this. And we can change all these lamps. Now I think the 3 center lamps were working and the 2 outside ones are out. So what I'll do is I'll just replace all 5. That way I know one of the older lamps won't burn out in a month's time. So I got 8 volts here in my power supply. Just out of curiosity, I want to see which ones are burned out. So I'm just going to connect these up. That one's definitely dead. Oh, that one's working. Put that aside. It's really, if you look at these, the inside of the glass is kind of smoked, so they're pretty much at the end of their useful life. Just going to pull these all out. Yeah, I had 3 of them that were working, and 2 of them that were not. So I'm going to put in, these are brand new, 8 volts. And these lamps run at 200 milliamps. 200 milliamps, 8 volts. I bought 100 of them, so I won't be any shortage of lamps now. I had a hard time finding them, but I did find some on AliExpress from a bulb manufacturer, and he sold them in the 100 lot. And actually it wasn't too bad considering I think they're like 50 cents a piece or something. I like going with original incandescent as opposed to putting in funky LEDs that have weird colors. I'm not a big fan of that. Having old Marantz receivers with the glowing blue face that has the artificial blue on it, it just doesn't work for me. So I like putting in original incandescent lamps. So that's all done. That's relamped. I can screw that back down. All of these lamps are working as far as I can recall. I'm going to test them again, but I'm pretty sure they're all working. So there's no need to touch any of these indicator lamps. There's, let's see here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 of them. And yeah, does that include the stereo lamp? Where is the stereo lamp? Stereo lamp is down here. Yeah, I think that was working as well. Meter lamp, same thing. Maybe I'm going to take this meter lamp out. And it looks pretty dim, so I'm going to change it anyway. It was working. Let's pull this meter lamp out. Okay, so there's our meter lamp. This one was working. Yeah. Put a brand new one in here too. Okay. Next we'll be replacing the lamps in the faux oscilloscope display. It's actually just an output power meter. But I'm going to wait because I have these 4 potentiometers on order. I'm going to replace these 4 pots and I'll do that all at the same time. And I'll take this assembly out. We'll go through it and we'll change the lamps, make sure it's all 100% before we put it up back in. So I'm going through this 4-channel decoder board. What do they call it? The sub-channel circuit. That's what they call the sub-channel circuit, whatever that means. But it works on a principle of there's a recorded on the album or in the FM source. There is a 30 kilohertz what is it? Subcarrier, I think they call it, and it works kind of like FM multiplex in that there's another channel that's encoded into the program source. And I was sitting here recapping this and thinking to myself, you know, I don't really know how this works. And to be honest, I've never heard in my life, I've never heard 4-channel audio. So I'm kind of curious as to what that sounds like. I think it's going to be kind of a cool experience. I know it was a big thing in the early 70s. I think Pink Floyd, Dark Side of the Moon was recorded in the studio to accommodate 4-channel. And I think it was mixed down to 2-channel for the album. But I think you can obtain it in 4-channel format if you buy it on tape or the CD for encoded records. So what I did is I did something a little different here. I went out and found this CD4 adjustment record. This is from JVC. It's a 4-channel CD4, 4-channel stereo quadradisc, compatible discrete 4-channel disc, stereo disc system. And this is a test record. It has an introduction, 30 kilohertz carrier level adjustment tones, CD4 adjustment tones, channel balance adjustment tones, and then channel identification. And then I think on this side it has the exact same thing. I thought it would have some music. Okay, it doesn't. But yeah, we're going to go through this and experiment with this. And I've never heard this before. So this is going to be a real treat for me. And I know it won't come across on the camera. But maybe I can give you my take on what it sounds like. But that's towards the end of this video. We're going to, not this video, but the video series. We're going to test this out. I don't know if you can see this, but you see the contacts have a small amount of pitting on them right in the center of the contacts, and they're still tarnished. These are silver contacts. Let's look at the other side. The other side is not used. There's no current going through them, so they shouldn't be pitted at all, and they look pretty smooth. But the contact side of these contacts, or the business end of it, yeah, they got some pitting. Oh well, that's showing up on camera. Disappointed that my cleaning didn't do anything. Kind of made it a little better, but it didn't take the problem away. So I'm gonna get a little more aggressive with my cleaning technique. So what I did is I took a popsicle stick and I cut out some scraps of sandpaper, different grits. I got 320, 600, 800, 1000, and I got this sandpaper out of the garage because I do a lot of auto body work. So we're just going to lightly go over this with the 320 first. And you can see it's scratching it up pretty good. Not really taking off much material. Just want to really lightly do that and have a look at them. I just want to get rid of those pits. And I think I'm successful. Okay, so I think this one's a little bit and this one a little bit. So I think we can go up probably 800. We'll see how 800 does. And take out those 320 scratches. That's looking a lot better. Let's go to 1000 now, and we'll very lightly, don't have to put any pressure on these. And that cleaned up those contacts a lot better. These are silver. Silver contacts, let's see here. Yeah, they're silver all the way through. And what they do is they have an arm, whatever the arm is made of. It's made of some kind of a flexible, usually it's, it's usually called beryllium copper, which is an alloy of copper and beryllium. They have bronze copper as well, spring bronze copper. Sometimes these look like they're plated. Who knows what kind of metal the arms are, but the bullet, the little end is silver. It's a silver button, and then they put it on there and they crimp it. Looks like I got it cleaned up pretty good. And yeah, that tarnishes and oxidizes, and that's what gives you your flaky connection on your speakers. So I'm going to leave this side here. I'm going to try with, first I want to see how they are lined up. If one of them is bent out of position, that could be a problem. And I think they're all good. So I'm going to just go straight to the, let me take a look at the, which ones, oh, I'm looking at the wrong ones here. I'm going to look at the top ones. I don't see much pitting on them. So I'm going to go right to 600. And yeah, I thought so. This is a little too thick to fit in here. And I don't want to jam that in there because it's really not a good idea to use such hard abrasives. So I'll get a little piece of sandpaper and I'll clean these top rows of contacts here just to take the tarnish off like I did. I'll probably start with a 320 and jump to an 800, maybe then 1000, and then I'll put this back together. This side is done. What I could do is I could also go up even higher. I could get 2000 grit or 2500, and I could actually even put a little polish on those with that, with grits that fine. But I think 1000 is good to leave off with. I think it's going to be okay. And we'll test it again just to make sure it's working. All right, so I got it. I had a piece of 1000 and I wiggled it in there with a screwdriver tip. kind of like this. Put the screwdriver tip on the back side and just wiggle it in there. But it works. It cleaned it up pretty good. Now I need to reassemble, but before you reassemble, you got to flush all that grit and crap out, and you need a zero residue cleaner just to spray it, flush it out, and then allow it to dry before you reassemble. So I can put this back together now. And it's going to cooperate with me, or is it going to fight me? What's holding it up here? Okay. Spring. Oops. Okay. It's on there. So I'll put that back in. Make sure the wires aren't pinched. And they're free. Now if I really was anal about this, I could probably hook up an ohm meter and check the contact resistance and all these and confirm that they're all working, but I have no doubts that it's going to be good now that I've did some aggressive cleaning with some sandpaper. I really don't like doing that, but it's a last resort. This can go back in. Make sure it's not binding anywhere. And of course, you always got the option to replace the relay. Okay, whatever engineer at Pioneer thought this was a good idea should be fired, I think. Or maybe he was fired, who knows. But this power amplifier is not easy to service. It's not easy to remove to service, let's put it that way. You pretty much got to disassemble it in place, which is kind of a piece of crap. Like, you got the heatsink in the middle. You've got your driver board on this side, driving all your transistors, and your thermal compensation diodes are here. And then on the other side, you've got your IPS and VAS, your input section, and your voltage amplifier section. And this side is easy to get to. I had to take out this plate and take out these two side pieces. It's pretty much you have to disassemble it right in place. But I want to get this heatsink out because two things. I want to clean it because this is part of the problem why this thing stinks, is because the heatsink needs a cleaning. And this is your big heat emitter right here. So anytime this warms up, you're going to get nasty smells off of it. Plus, I don't think there's any heat sinking compound on these transistors. I don't see anything that's been squished out. If there is some there, that's very minimal. So I want to take these transistors out and clean the heat sink and regoop those with heat sink compound so that we know they're good. But this is a pain. Look at this. You can't get this plate out because all these wires are in the way, and you can't really pull it out the bottom. Maybe I can, I don't know. It's just not, I don't know who designed this. Maybe it all comes out this way. But there's so little room. If I pull it out like this, I'm still getting hung up. Yeah, this is, I don't know. Oh, hang on. Maybe I do get it. If I can get this one out. This one's tight. So you don't want to get any wires pinched because they might get cut. See that? This comes out the top. There we go. Now I can disconnect all this. This thing's stuck in the middle, it's in the way, so I have to get this out. There we go. I have to remember how that goes. So this is the rear plate, this is the front plate, so mark rear on this one. rear. I'll put a little arrow for top. I'm going to clean all this stuff anyway, so it doesn't stink after, but at least I got this apart now. I can at least work on these two boards, and I can disassemble everything on this heatsink. Okay. One of the good things about this Pioneer receiver is I haven't found any cracked solders yet. The soldering on these boards are pretty good. No complaints. Even with these posts, they have all these posts with the wire wraps. Usually those are your first spot where you're going to find a crack. But you know, these ones are good because they're folded over, and there's like double pins on this side, so you get twice the grip on your solder pad. Some of these other ones have just a single post through the thing, but yeah, no cracked solders I've found yet. Maybe I will find one here. So next step is I'm going to disassemble this, and I'm going to take this all apart. It's just sockets for the TO3s on the back, and then there is 4 screws for the thermal sensors. And then I can take this apart, clean the heat sink, and then we can start reassembly. There's a couple of capacitors on this driver board. I think there's 2 or 3, 4. I'll replace those, and we'll go through and we'll check everything else, and then we'll start putting it back together. Alright, so I got most of the screws out, except for one. These pairs of output transistors are wired in quads. So you got these 4 transistors are kind of wired together, and they're held by these harnesses, and then these 4. And another thing I didn't notice until just recently is they have different transistors for the different channels. This one's a 2SD370. This one's a 2SD371. The 2SD370, 371. Now, I don't think these transistors have ever been touched by anybody outside of the factory, but I believe the front channel, which is, I think it's, I don't know, it's 1 and 3, channel 1 and 3, or is it 2 and 4? I don't know, is a little more beefier because it's configured to run at higher power in 2-channel mode. So you can actually, from the back here, you can switch it from 4-channel to 2-channel, and it ups the power from the power transformer, and you get more power out of those 2 front channels as you would if it was in 4-channel mode. Anyways, but let's start pulling these transistors out. You have to write down their location, which I did, so that I don't mix them up when I put it back together. And I'm just going to pull some of these transistors out. Pretty crusty, and they look absolutely dry. The mica washer is completely dry. I don't know how they did that with no compound. The heat transfer on that must be terrible. But we're going to fix that. So I'm going to pull all these out. And look how dirty that is. It's all kind of orange. It's kind of orange from the smoke. Maybe I'll dump these in the ultrasonic and clean them up. But I'm really not happy about the mica washer situation here. What I should do is put sill pads on all these transistors and give it a fighting chance. That one is, yeah, this is not good. They are socketed in, and I'm just pulling them out of the sockets. Huh. I think I'm going to have to put sill pads on these, or at very least regoop these with some heatsink compound. There's nothing on these heatsink. They were put on dry, which is kind of a disappointment. I don't know why a Pioneer would do that. So anyways, let's get all these out. because we have to clean the heatsink. Okay, I have the socket assemblies are still stuck to the back here, which is good. Okay, so I got one more screw to remove, so I was just leaving it for last. And then we'll pull out the last transistor. And we'll see if we can get these to disengage back here. They're kind of stuck on with age. Oh, that one's really on. They might have used some kind of glue on here. Okay. Yeah, they had some kind of glue on here. What is this stuff? I'll get this cleaned up. It's quite a heavy heatsink. It's got some mass to it. And here's our sockets, all 8 of them. So now I can service this board, can service the input board, and then we can get it all assembled again. You can see here on the driver board we got channel 1 and channel 3 has heat sinks on the driver transistors. And the other 2 channels, these are the rear channels, don't have any heat sinks. So it's kind of obvious they're using these 2 channels, the front channels, as a high power output amplifier. And the other 2 are just kind of, I don't know, lower power slave configuration. But now I got full access here. I can change these 4 capacitors. I'm pretty sure they're tired. And I can go through and check for solders. I'll probably end up adding a couple heat sinks to these 4 drivers here because, you know, the one I'm feeling left out. Even they downsized the emitter resistors too. Here we got, these are all 0.5 ohms, but this is a 5 watt and here's like a 2 or 3 watt. So there's a little bit of reasoning behind all their stuff here. And then I got full access to this board. There's about 20 capacitors on here. I'm going to change a bunch of Sanyo caps I'm going to get rid of and put film in. And we'll do the electrolytics as well. Alright, so I removed these 4 heat sinks and cleaned them up. They didn't have any compound on them. They just had some kind of glue. It looked like thread locker. So I'll put those back on the channel 1 and channel 3. These ones had them on. And I also made up 4 little heat sinks. These are little tiny aluminum extruded. I cut them up to the right length and drilled a hole and put threads for a self-tapper. So these will be on the ones that don't have any heat sink. They're going to be now heat sinked with a little bit of aluminum just to give it a little bit better thermal sinking. So I'll put those on, and this board's pretty much done. I got the new caps in. All I have to do now is clean it. Want to go over it with a fine-tooth comb to make sure I don't have any cracked solders. I don't think I have any, but I'm just going to resolder some of these joints, clean this side, and then it can all be reassembled again. So I'm working my way through the power amp here and just doing recapping on this. I've had some people ask me, why don't you show the recapping process so we can see what you're doing? And well, I could, but it's kind of boring, repetitive work, and there's nothing really exciting to see about recapping. I can show you a few things about what I do, just to make things go quicker, a little more efficient. What I do is I take this here's from the service manual, and I print off the pages that are relevant to the boards I'm doing. So this is the power amplifier section. We have 2 boards here. This board here is your input section and voltage amplifier section. And this board here is your drivers and output. Okay. So what I do is, since it's got 4 channels, there's 4 capacitors that are the same. So what I'll do is I'll go, for example, I'll go through and I'll pick out all the 10 microfarad capacitors and I'll remove them. I'll know where they are, and I'll confirm it on here too. I'll do it on this, and also I have it on this board. It tells me exactly the capacitor number, its value, and its orientation, right? It tells you transistor orientations too if you ever need to do anything with that. So I'll go through and I'll pick out all the, let's say for example, the 10 microfarads, and I'll remove them from the board, and I'll clean the board where the solder pads are, and then I'll insert 4 new capacitors, and then I'll do it that way. The reason that's quicker, well, usually I do it 1 capacitor at a time, and I'll take out 1 capacitor, replace 1 capacitor. That way there's less chance of getting confused as to which capacitor goes where, its orientation, and so forth. So with this Pioneer receiver, I've been doing a lot of this multiple capping. So like for example, I took out all these 330s and I replaced them 4 already, and then I took out these 22 microfarad caps. They're little tiny ones, you probably can't even see them, and I replaced those 4, and now I'm going to do these 3.3 microfarads. These are 3.3 microfarads at 50 volts, and there's 4 of them, 1 for each channel. So I'm going to just pull these out now, and I just pull them out with a soldering iron. Just do this in real time so that you have a idea of how long it takes. And I make sure this board is marked with positive as opposed to negative. Most boards are marked with negative. This one's marked with positive, so I might make sure that capacitor is orientated right and pull them out. There's 2 more. Come on. Okay. We've got our 4 caps out. Let's have a quick squint at how they look. So a 3.3 microfarad capacitor at 50 volts should have an ESR between 4 and 10. Okay, so just keep that in mind while I test some of these. Okay, let's try the first one. This one comes back at, what's going on here? This one comes back at 3.9 microfarad, which is high, and it's got a 43 ohms, which is no good. And this is fairly typical of what I've been finding all throughout this receiver. 4.2 microfarads, which is high and out of tolerance, and high ESR. Yeah, pretty consistent with all the other capacitors I've pulled out. They all read high on the meter, and they have a high ESR. The reason they read high microfarads is because they're leaking, and they're tricking the meter into thinking it's a bigger capacitor than what it is. There's the third one, 4.3 at 31. The last one, .4 at 22. So those 4 are shot, and that's mainly the reason why I've been changing these. Now I got the caps out. I'm going to clean the holes, and I use a solder sucker. I'll just go through and clean the, suck off the old solder. And you can use wick. I don't like wick, it makes a mess. But I'll be cleaning these boards anyway, so I just use my vacuum machine and it works quick and easy. Alright, so I got 4 capacitors here in case you you don't believe me, here, let's look at this. Let's look at this capacitor and see what it says. So here's a new 3.3 at 50. It measures 3.4, which is intolerance, and 7 ohms ESR, which is pretty good. So every capacitor has an equal length of leads. The long one is your positive, and the short one's your negative. And I think they do that for a reason, just so that the automatic inserter machines know the difference. But I'm just going to insert these in. The long lead goes into the positive hole, and the other lead goes into the negative. Just insert these 4 capacitors. Okay, let's see. This one's got a blob of solder in it. Nope, not anymore. Just give them a little spread so they stay in place. Okay. Solder these in. So what I do is I'll go through and I'll solder one lead of each capacitor for 2 reasons. One reason is so that you don't get too much heat on the capacitor. Kind of evens it out, spreads out the heat between the different caps. So this one will have time to cool before I get back to it again. Second reason is so that when I'm done this one side, come on. Okay. Second reason is when I'm done this side, I can go through and I can straighten them up, make them all look pretty, and then I can go solder the other one. That's it. Snip the leads. And then inspect after you're done. I'm going to inspect the whole board. After I finish replacing these 8 capacitors here, I'll go through and inspect it and clean it, and then we're done. So that's it, yeah, recapping. So I've got 3 caps in each channel replaced. I still have 2 left. Nice build quality on these Pioneers. Is, like I said, I haven't found any cold solders, and you know, the boards are fairly good. Elna makes these boards. You can see their brand in Elna. Have a look at this. I'm trying to clean this crap off of this where I get it in field. They painted something on here on the aluminum, and that's what I guess they were using as a heat transfer compound. But it's hardened and it's like an adhesive. But I can't seem to get this stuff off. Alcohol doesn't want to touch it. I think I might have to take this outside and use some more aggressive solvents, maybe some lacquer thinner or brake cleaner or something. Let me see here. You can see it bled through to the back side on some of these, and they painted it on. There's some there. It kind of scrapes off, but I don't want to scrape it and then butcher the heatsink. I want the heatsink to look nice. So I'm going to take this and maybe try spraying it with some kind of a solvent, see if I can get that stuff off. I'm putting it back together because I finished recapping these 2 boards. I finished my inspection and cleaning. Everything's good to go back. I cleaned the heatsink and it was quite a hard thing to clean off. It needed some lacquer thinner to get rid of that adhesive that they use to glue the transistors on. And the same adhesive is on the back of these transistors, so I got to clean these off as well, which is no big deal. But I'm just starting to reassemble everything, and the main thing is getting the transistors in the right orientation. I got my map here that I drew out before I took it all apart. Top of the heatsink, which is here, and then which transistor goes in which location. So I got to get that sorted. You don't want to mess that up. And then we'll get this thing all back together and back into the thing. I'm tired of having this thing hanging its guts out all over my bench, because I got other things I'd like to work on too, and I could just move this out of the way, but I don't want to move this when it's all hanging in pieces like this, because things get snagged. And so I'm going to put this all back together, hopefully get the power amp back in today. And I started doing a little bit of cleaning on the back panel. It was filthy, along with the front panel. Let me show you the front panel. Here's the front panel. You can see the filth on it. And I'm going to give this a good scrub as well, and make it all sparkly again, and turn this into a nice unit once more. Okay, just going through and replacing the power transistors, and I think I stumbled onto my first trap, which is the orientation of these transistors. Along the bottom here we have the NPN transistors, and on here we have the PNPs. Now one would naturally assume that these two are for one channel, these two are for one channel, and so on, but that's not true, because the transistors are laid out like this. The NPNs have a short wire leading directly to the heatsink, but the PNPs have a longer wire and they cross, so they are effectively crossing each other. So this is one channel and this is another channel, and I can see why they do that, because when it's set up for the 2-channel high power mode, you don't want these two transistors putting out heat and these two transistors putting out heat and these doing nothing. You want to spread your transistors out diagonally like this, so that the heat generated by these transistors is effectively coupled to the heatsink and released into the air. So I can see why they did that, but it's something you got to watch for. You got to make sure that these are in the correct position. Not that it would matter if you actually swap these two transistors around. They're both PNP. They're very similar part numbers. I suspect one is a little higher current rating than the other. That's the only reason why they're using it like that. Wouldn't make. I don't know why they would do that. They should have just used the same transistor in the entire amplifier and made it easy. But this is the way they did it. So there's one trap to watch out for. So check out these bad boys. I got these in the mail. These are exact same size as the originals. Let me flip this around. I'm getting hung up on everything here. These are the exact same size as the originals physically. That's why I ordered them. Same diameter, same length. But these are 10,000 each, and I measured them, and one is a little above 10,000, one's about 9,000. So I decided to change them both out because they're not balanced properly. But these are 15,000 and plus minus 20%, 63 volt capacitor. The reason I went to 63 volts is because I could only get them in the 40 millimeter. Where's my? Yeah, you can only get the 63s in 40 millimeters, not the 50s. The 50s come in a 25 millimeter, I think, or 30, something like that. So yeah, I wanted to retain the original physical size so that they bolt into the clamps and they look proper. Another reason I picked these is because they have solder tabs. I can hook wires in and solder, whereas the originals had wire wrap posts, which is not a big deal. I can unwrap these and then do solder tab, and everything will be good. I even paid extra for the gold lettering. How about that, eh? So yeah, these are a little bit of an upgrade for this amplifier. This is going to give it a little more kick at the top end, and yeah, can't wait to get these installed. So I'll do that next. Got a little wiring thing here. The two black wires goes to ground chassis, Okay, that's my common point between the two capacitors. The 4 red wires, that's my B plus. The 3 orange wires is my B minus. So you got to make sure you get those right. And then the white wire is my center tap from the transformer. So I got all these wires to deal with. I'll unwrap some of these. Some of them are soldered, some are wrapped. So I'll undo all that, install the new ones, put it all together, and get it all soldered in. On to the removal of the level power meters. So I removed the 2 screws, and there are a number of wires here. So let me explain what they are. There's a black and a blue. Black and blue. The black is your ground, and that goes back to the illumination board here for the dial lamps. Your blue is your power for your lamps, and then there's 4 wires here for the meters. There's a, in their label in the back here, channel 1, channel 2, channel 3, and channel 4 at the bottom. And each wire, each channel has its own color-coded wire. So what I did is I made a diagram of what's here, and now I know how to rewire it when I'm done. So it's just snippy. I'm not going to desolder any wires here. What I'll do is when I'll remove it, I'll clean the solder lugs for the wires. Let me see if I can see this one here. Okay, snippy. And out it comes. And there's a lot of black wires hanging in here. These are all ground wires for the meters and for the lamps. Let me just pull this out. Okay, and there it is. So let's work on this. Okay, so what the heck is this thing? This is just a, well, it looks like an oscilloscope screen, but it isn't. It's just a plastic green filter with some graphics on it. What it is there's 4 meters in here. You can see they're marked channel 1, channel 2, channel 3, channel 4. And there's also 4 lamps, 1 for each channel. So there's our 4 lamps, and they look pretty much perished. Let's put 8 volts to them and see what they do. Okay, so we got 3 lamps. They're pretty dim. Filaments bouncing around inside there. So I think the first step is to do a LED retrofit on this. I wonder if this screw removes the back cover. Ah, look at that. Okay. So what these are, they're actually just shutters, and depending on how the music's going, these will deflect like a meter. And the more it deflects, the more it opens up and allows light to come through from that little square. Let me shine a light through here maybe. You can see that on the camera. You shine a light through there and it kind of deflects and makes 4 beams. So, aside from cleaning, there's really nothing to do to this. In applications like this, I'd rather use an LED, I think. Let's get a warm white. You can even get green LEDs. So these are just in a rubber block. It's really soft rubber, but they're glued in as well. Let me think about what I can do here. Okay, so the first step in any LED conversion is you need to know what your supply voltage is going to be. And here I'm using a tap off of the lamp supply, and it's usually an AC voltage. Got it hooked up. I got my probes to the wires that are supplying the meter, and we're going to turn it on. And we got 7.9 volts. And that's our basis for calculation. Okay, so I got the 4 LEDs mounted on the board the way I want it. I think they're positioned in the right position because they have to align with these little apertures. Test this out. So let's put this on. Let's mount this on the meter with screws. And then let's power it up and see how it looks. And see if we have to make any adjustments. We might as well do it now before we get too far ahead of ourselves. Okay, so that's in its mounted position. I have a 1K resistor here. I'm just going to solder it in on this right here, just so that we have something to test with. And we should see all 4 LEDs lit. Okay, let's turn off some lights. You see, that's quite dim. I don't think this one's aligned properly because I'm not even seeing it on the... Yeah, it's way off. Let's turn up the voltage. So I got it about 14 volts right now. And you can see, if you can see, the 4 meters, I can see them, but they don't look balanced. Okay, I'm going to have to adjust these LEDs so that they're more in tune with the aperture, because I got a couple here that aren't quite there yet. Pretty close. Okay, we're getting it. Okay, I'm just running a test with my signal generator. I'm feeding it triangle wave. Oh, what am I feeding? 1.4 volts peak to peak, and it seems to be maxing out. So I'm just testing this 1 hertz signal, testing each meter, and it's getting fairly good brightness. One thing I noticed, switching from incandescents to LEDs, this image is a lot more crisper. It's a lot more focused. I think that's a good thing. So let's try the other ones out. Let's try this one down here. That one's working as good as well. And this one over here. Everything seems normal. Let's try the last one, if I can find it. There we go. I'm feeding it probably about, each string's probably got about 9 milliamps through it. Alright, so I took my Dremel and I made some cuts. I cut the trace here and I cut the trace here just to get rid of this bridge, and then I cut the trace here and cut the trace here, and then I tinned a bare portion of it. And what I'm going to do is I'm going to use a 470 ohm resistor, chip resistor. These are quite tiny, so I'm going to try soldering these on camera here. Might be a challenge, but let's try this. So I'll pull this back and drop the chip resistor here. Very tiny. Now I think what I want to do is pin that down. Ouch, that hurt. Yeah, oh no, it wasn't soldered. I thought it was. Let's try it again. It's kind of hard to do around a camera, but we'll keep trying till we get it. Okay, right there. If I can pin that down. And it moved on me again. And that time it took. So let's try this. You know, what would help is if I clean my tip. Big chisel tip. Doing SMD with a big chisel tip, eh? Who would have thought? Okay, let's get this right. That into position. Right there. It's done. Solder the other side before it moves. Try this one more time. Good. Now we just need to do one more. Are you kidding? Where'd it go? Oh, here it is. Okay, I found it. Bugger was right in plain sight. There's a little magnetic here, I think. This is not good. I'm going to switch tweezers. Okay, this is better. Okay. If I can get it into position, I can hold it with the screwdriver while I tack it down. There we go. Can you see that thing? It's so small. It's all crooked now. Okay. Solder the other side and we're done. And let me inspect. Both good. So if I put voltage onto this and that's too much power here. We need to turn this down because this is what I need is 10.5 volts. Okay, 10.5 volts. There we go. And that's what it's going to operate at. Approximately 9 milliamps through those LEDs. They get a little warm. If I calculate the power, it's probably 50 milliwatts or so. But that looks like it. Now I need to create a little power supply in the in the receiver to power this, and that's just a simple matter of getting a capacitor and a diode together and wiring it in. Okay, so every time I do an LED retrofit, I kind of want to go through the math of it to kind of explain to you how I determine how to set the values for the resistors, you know, what I'm working with. And this Pioneer is no exception. So the power transformer has a primary 120 volts AC, or it could be 240 or 220 depending on the country you're in, and that's nothing we can control. But on the secondary, they always have, well, usually, I'm not going to say always, they usually have a winding with a center tap, and this goes into your bridge rectifier, right? And this provides your plus minus DC voltage for your rails, and your center tap is usually grounded. And that's how they usually do the B plus, B minus for the power amplifier. Amplifiers of this vintage usually use a split power supply, the plus and minus. Some of the really old style amplifiers didn't use this, but anyways, we're not talking about this, we're talking about lighting. So Pioneer, Marantz, Harman Kardon, a lot of different manufacturers, when they have incandescent pilot lamps, they have another winding added to the transformer, and this is usually 8 volts AC, because I don't know, they just loved 8 volts for some reason. And what they would do is they would stack their bulbs in parallel. I'll just draw some bulbs in here quick, if I don't screw it up. And they put as many as they want in here on 8 volts. Sometimes they'd have like 6 or 10. And sometimes they would put a fuse in here just to protect this transformer winding and to protect the circuitry. And this is exactly what Pioneer did in this receiver. They put an 8 volt AC winding on their transformer, and then they tap in as many bulbs as they needed. Now, when we look at this, originally these 4 bulbs were all wired in parallel, just like this. And this black wire here was one of the connections for the bulbs, and this was referenced to ground. And the other one, there was a blue wire going back to the other lighting board, and that would be your 8 volts AC coming in. So this was run off 8 volts AC. So what I did is I removed those 4 bulbs, put LEDs in, and I'll show you what I did here. So what I did is I went with 2 strings of 2 LED lamps in series. So let's draw this in. We've got 1 LED here, 1 LED here, and then another string there. So that's effectively what I've done with this circuit. What I've done is I've cut traces with my Dremel, and I'm not using this connection, I'm using this connection. So actually I have the negative connection here on the bottom, and then I have an LED and another LED in series, and then it goes through a dropping resistor. You can't see the dropping resistor, it's pretty small. And then it goes to this pad, which would be my positive connection. And this would be grounded. Okay? So each voltage drop on an LED is approximately 3 to 3.4 volts. Okay, this here I measured. This is 7.9 volts AC. Now what we want to do is we want to convert this to DC, so I'm going to put a single diode in here to halfway rectify this. And anytime you anytime you rectify AC to DC, you have to multiply by 1.414, because what you're doing is you're converting it from an RMS to a peak, and you want that formula. So 7.9, here, let's try this. I'll find my calculator. .9 times 1.414 equals. So we have 7.9 volts AC equals 11.17 volts DC. But we have to remember we're going to lose 0.6 volts here, voltage drop across this device, right? So we have to minus 0.6 volts, and that puts us at 10.57 volts. Follow me so far? I hope so. So this is what the voltage we're working with, 10.57 volts. Now, minus, we have to minus the voltage drop for each of these diodes. So if we add up two of these diodes together, let's go with the middle of the road value of 3.2 for each diode. 3.2, 3.2, so that's 6.4. That gives us 4.19, or 4.2, let's say. And that's going to be dissipated across these resistors. Now, this is where we need to make a decision. How much current do we want to run through these LEDs? Because we could run anywhere from 1 milliamp to 100 milliamp through these LEDs, depending on how bright we want them. The higher current we run through them, the less life they're going to have, because they're going to heat up, they're going to thermally cycle, they're going to, eventually they're going to die. So we want to keep the current as little as possible, but we want the brightness as high as possible. And I decided on, actually what I did is I decided on 5 milliamps, and I hooked it up. And I tried it with 5 milliamps, and it seemed like it was a little too low. So what I did is I doubled it to 10 milliamps. So let's go with 10 milliamps. That's our target. That's our target. So let's say we want 10 milliamps through here. So we have to adjust this resistor to allow 10 milliamps at 4.2 volts. So R equals, here's your Ohm's law, R equals E over I. So we know E equals 4.2. I is in milliamp, or is in amperes, so we have to go 0.001 for, no, hang on, that's not 100, 10. We got that wrong already. So I get tripped up when I convert. Okay, so 0.10, that's 10 milliamps. So if I do the math on that, we get 417 ohms. Now, we have a little dilemma here. We don't have a resistor that measures 417 ohms or even 420 ohms. What I have is I have a 390, that's a standard value, and I got 470. So I got a choice here. I can go up or down. If I go down in value, the current will go up, which will put us over 10 milliamps. If I go up in value, the current will go down, which will put me under 10 milliamps, which should help with the life. The brightness between these two probably be hardly noticeable, but I'm going to go with this one, 470 ohms for these resistors. 470 here, 470 there. Let's connect this up, and it should work, right? Well, almost. what we're going to do is we're going to be doing halfway rectification here. So it's every there's the AC, and then when we halfway rectify, it goes like this. We cut off the bottom. That's what this diode is going to do. It's going to cut off the bottom, and it's going to produce only positive pulses. And these pulses are going to be 60 per second. And what it's going to do is it's going to go on for a few milliseconds, go off for a few milliseconds, on and off, and the LED is going to strobe. Something we don't really want, because you can actually see this strobing in these LEDs. They're fast enough to come on and off to show that strobing, and it's not a very pleasant light. If you look at it, it's kind of a, your eye can detect it, and it's not as pleasant as having a steady light. So what I'm going to do is I'm going to add a capacitor here, and I'm going to size this. I can size this anything I want, but I can go usually between 10 to 100 microfarad. If I go too big, when I shut the receiver off, these LEDs will stay on and they'll slowly die away, and it kind of I don't know, it gives an odd, eerie feeling when you turn off something and the lights stay on. That's not right. When you want to shut this off, when you turn off the switch, you open the switch, you want this to die relatively quick. You don't want it to stay on and linger for a long time. So I would probably go 47 microfarads, or maybe even 100. We'll try 100. We'll see how it reacts. 10 is okay too. Maybe I'll try 47. Let's go with the 47. There, and that will filter out all of this. It will probably make it look like this. The voltage will ripple, but it won't be on and off, so it'll be better. Now, you're probably wondering, how much current does this thing consume? So let's figure it out. Let's figure out the current for these. So I equals E over R. So we have, for example, we have 4.2 over 470 ohms. So we're going to get 8.9 milliamps on each leg. 8.9 plus 8.9 is 17.8 milliamps total. And that's what this diode is going to supply. So we could actually calculate the power that this is going to consume. So we know our full voltage here is 10.57 times, oops, messed up, times 17 milliamps equals, and our total consumption will be 179 milliwatts, which is pretty much nothing. So that's pretty much it in a nutshell. I think this will provide bright light. It'll provide a focus light, and it should last a long time. It should last indefinitely. If these LEDs are of reasonable quality, I know I got them from China, but if they're reasonable quality and you don't overdrive them, they should last indefinitely. So we're going to go with this. All right, before I install the meter back in its resting place again, what I want to do is I want to modify this to provide me with DC instead of AC. These are the cut wires. There's 4 cut wires here from the meter. The black wire is my ground. That's common ground for all the meter movements and the LEDs. This blue wire is going to be my power feed for the LEDs. And this blue wire comes from, where does it go? It comes from right here. Let me see. It comes from right here. And it also feeds something else. It goes back here. I think it feeds, I'm not sure what it feeds. But what I want to do, this blue wire comes from the power board, and I checked, and it comes right off of a fuse that is in between the transformer and this wire. So it comes off a fused line. This is a fused line, and this is a feed line here, and this is the line that's going to go to the meter. So what I want to do is install a diode here. I want to cut this trace. Here, I'll zoom in a bit. I'll show you what I want to do. I want to cut this trace, and then what I want to do is I want to take a little surface mount diode and just solder it in here. But I can't, because the power is feeding this way and this is feeding something else. I don't even know what it is. So what I'm going to have to do is swap these two blue wires, and then I'm going to have to turn the diode around and install it that way. That way the power feed will come in through here, feed this, and then this will be cut. It'll be rectified by the diode, and then it'll be DC through this line. So let's get started. I have my Dremel handy. So let's cut that open first. Watch your ears. And remove all the solder mask too. Ouch. Okay, let's cut this. Okay. Just gotta be careful with the copper dust I create is conductive. You have to make sure it doesn't get into some delicate stuff, but I don't think we're okay. Let's just wipe this out. I think that'll work. I think I should be able to solder this right in. Like that. The reason I can do this is it makes it less obtrusive. What I could do, there's nothing stop. I could just put a diode between these two posts, wrap the wires around, and be done with it. And no one would be wiser. But yeah, let's. We got to unwrap these wires first, though. Let's do that. I'll come back when it's done. Okay, I pulled the two wires off, and I scraped back the solder mask a little bit more. So what I'm just going to tin those pads for that new diode. Actually, clean the tip first. Clean it one more time. Okay. Okay. So it's a simple matter of picking up the diode, getting it orientated right. See if I can. The line's on this side, so that would be my positive. So let's put this in place. Come on. Okay, I think we're in. Good enough. Now, we'll hook up our feed wire. This is our power feed. I'm just going to strip a little bit more off. It's a little shy. Got not quite 1/4 inch there. So let's wrap this around this post. power feed. Now this is going to go against what the service manual says for wiring diagrams, so, but I think the tech that comes here in the future will be smart enough to figure out what I'd done. So here's our wire going to the lamps. Cut this short. I'll feed this one around this post. And solder it. Alright, so there it is. New diode installed. I'll clean that up with some alcohol. Yeah, that'll provide us with DC current now. And that'll be whatever's fed by this line here will remain uninterrupted. I think this goes back to, yeah, it goes back to the other lamps. There's five of these fuse style lamps. If I tip the camera up, you can see it yourself. This side of the lamp is connected to the ground. This side of the lamp here is connected to this wire, which comes from the power feed. Alright, everything's good. And like I said, you don't need to go to the surface mounted option. You could just tack a regular diode between those two posts, and just wrap it around, solder it in, and you're done. Just make sure you cut the trace below it. Alright, sometimes I get requests for part numbers because I go through a repair and I put in new parts and they say, well, what part was that? So here's a part number for these two capacitors that I purchased and put in. These are the old ones. These are the old Elnas 10,000 microfarad 50 volt. And these are the new ones. They're Cemet, C-E-M-E-T, made in Portugal. Here's the part number. I don't know if you can read it. Let me zoom in. Here's the part number. And these are 15,000 microfarad, 20% tolerance at 63 volts. It's okay to go up in value in voltage. It's not okay to go down in value in voltage. But I think this circuit runs at, I can't remember now, I think it's 40 some volts. So the 63 volt capacitors will just do fine in this. It's not like I'm putting a 100 volt or a 200 volt capacitor in and running it only at 40 volts. That's really not. They ran me about $15 each, and that's my Canadian price. If you're in the States, it'll be cheaper. Alright, so we're slowly chipping away at this thing. This is like I said, this is quite a beast. There's a lot to it, and a lot has to be done. All the boards have been recapped except for the tuner. I still haven't touched the tuner yet. The power amplifier is done, reinstalled. I still have to clean these back connectors. That's why they're loose, flopping around. I'll get to that. I still need to deal with this switchboard here. I got it loose. I got the screws out, and it's flopping around, but I can't access it. I have a decision to make here. To disassemble the whole front to get at this board to do a proper service. See, look at that button stuck in and it won't pop out. These buttons are very cruddy. I could go the easy way and just spray some stuff in. One of my viewers and one of my clients, Mike, was generous enough and kind enough to donate a can of the Deoxit D5. I don't have this in the spray. I have it in the concentrated liquid, but this would work for spraying into the switches, and that would be the quick and dirty way of doing it. I don't know if I want to try that, although it would work. It would probably leave a mess inside there, and also I kind of like to get my eyeballs in there too to inspect everything, just to make sure everything's good before I finish a receiver. So yeah, it was very, very kind of Mike to make this donation to the channel. I appreciate that. I think I might pass on that for right now, and I might just disassemble the whole thing, because this is the reason why. If I need to service the tuner, The dial string is going to need to come apart anyway. To get this tuner board out, the dial string has to be disconnected. Disconnect the dial string, then I can easily disconnect all of this crap on the front and get to those switches and then do it proper with the cleaner, and then two-step it with the concentrated D5 or deoxit D100, not D5. I also got another dilemma on my hands here. I ordered new potentiometers for the balance pots. Let me get one out and I'll look at it here. These are, pull this one out. Hang on, there's a screw hole. Let me get this screw out. There's a shield plate in here. Oh, that's tight. I'm just bending it. Wow, that put Loctite on those things. Or is it stripped? I don't know. It's never been apart before. I don't know. Anyways, they got little shield plates in here. Just this is the build quality of the Pioneers. This is what they go to. Got a couple of balance pots here. We need to put a little shield plate in there to protect it from noise. Anyways, let's pull this pot out. This pot has, my replacement pots have quite a bit of shorter shaft on them, you can see, and I don't think the knob would stick on. There's about 5 millimeters too short. Let me see if I can line these up. Yeah, 5 millimeters too short, I think. And the knob will fit on the shaft and push on, but I'm scared that there's not enough grip there to keep that knob on in place, and it might fall off in the future. So I'm not going to go with the brand new pots. Although this is, I wish I could, because you know it's always better just to replace a pot than to clean it. But not in this case. So I'm going to clean these, take them out and clean them properly. You can get at them very nicely here. All I got to do is just remove them from the chassis, and we'll clean each one, and then we can reassemble with the repaired scope. And then what I'm going to do is I'm going to remove this front and get at those switches, and that'll be it. And then I know it's done. I got a lot of cleaning to do here too. You can see how dirty it is inside. Even inside the dial glass, there's like, it needs a clean. So I'll work on that next. I think it's just going to be a big job. Shouldn't be too bad, I guess. Once the dial string's off, it should go easy. It's just a matter of doing a bunch of screws and keeping everything in place in my head. Power switch looks good. I'm not going to do anything with that. And the other pots have been serviced, except for these balance pots. I'll do that next. Okay, just to show you a little bit of what I've done. Removed. Let's see what I removed here. A lot of things. I removed this metal piece that kind of surrounds the dial face. That comes out. And then I removed this bar that held in the dial. And this sits together kind of like so. And it pushes in. There's two push-in things here. And you just got to kind of get a little screwdriver in behind and wedge them out. And then the dial face comes out. And you don't want to damage that. I'm going to clean that. It's all filthy. Then there's two screws here on the top that removes the lamp assembly, and that just kind of lifts, sits in these two tabs, and lifts out. There's two screws here that holds the meter assembly in place. I removed all the nuts from all of the potentiometers and switches, the nuts from the headphone jacks. Still got one nut here. Put this away. I removed the dial string. You just gotta remove it from the drum, and then it all falls apart. What I did first though is I drew myself a little diagram of how it ran. which way the cord comes into the bottom of the drum, which cord comes to the top of the drum, how many wraps on each, 3 wraps on the control knob, 3 wraps on the drum, and how it's wired, the dial pointer. So this is kind of a good guide for me to put it back together. There's also something in the service manual that I'll show you, page. I removed the 4 balance pots and put them out of the way. What else? I removed 3 screws here, 2 on the side, 1 in the back, 2 on the side, 1 in the back, so those are all. So this thing should just lift out now. Oh, I got one more thing. The power switch has a screw on it. Actually, the power switch should have 2 screws. Why is there a screw missing? I don't know. Maybe I already took it out. So then that should be it. That should be everything disconnected, and it should come out. There we go. It comes out as one piece. Comes out with a flywheel. I can re-lubricate this now. I can clean everything. Oh, I got a washer here, a stray washer. I can clean everything so it doesn't stink so bad. I can lubricate all of these pulleys for the dial cord, and I can lubricate the shaft for the flywheel. And then this should give us full access to the board, and it does. I can remove this front plate if I have to get in there, but I think I'm good now. I can get in and clean these switches properly. I can inspect the bottom of the board too. I can lift it up and look at the bottom, so it's all good. Okay, so I got this apart. I'm doing the switches up, and I thought this would be a good opportunity to turn the camera on and show maybe some of the newcomers to the channel how I do my 2-step cleaning process for these switches. This one I cleaned just before I turned the camera on, and it's working fine now. This one here is sticking still. I don't know if you can hear it. You notice there's a difference between the way it clicks. It's kind of sticking, and when I bottom it out, it kind of sticks in its bore. So we're going to clean this switch, and I'm going to show you what I do. We got one of 2 options. Well, we got a number of options actually. We can do a lot of different things. 2 different cleaners. Both basically do the same thing. The one on the left, Electrosolve, is 0 residue, and it says it right here, 0 residue. This one here, Neutral, control cleaner for electronics, has a residue, but it doesn't say that on the can. It doesn't say anywhere that leaves a residue behind. Easy way to check. Here, I'll just get, I'll show you here a quick way you could check. Let's get a blank piece of paper, and I'm going to squirt Neutral on one side, and I'm going to squirt the Electrosolve on the other, and then we'll let this air dry, blow on it. And I don't know if you can see that, but the Electrosolve is completely evaporating. There's nothing left behind. But the Neutral is leaving a stain on the paper. That's one way you can check. See if your contact cleaner is non-residue. It's still wet. You can see it's still wet. And I sprayed about the same amount. So there you go. And these are highly flammable too. You gotta be very careful with them. They got a lot of weird chemicals in them: methyl 2-pentane, methyl 3-pentane, dimethyl 2,3-butane, dimethyl 2,2-butane, pentane, hexane. So there's a lot of nasty chemicals in here. You don't want to be breathing it in. You don't want to be getting it on your skin. You just want to apply just enough to get it into the contacts of the cleaner, of the switch. So let's go with the Electrosolve. This is one of my favorites because it is a non-residue. So what I do is, on these switches we're lucky. We got a hole on top. See how that sticks? This side does not stick because it's been treated. I'll just give it a shot in the top. If it has a hole in the top, that's great. What I like to do is flood it and then work it. And I might do this for about a minute or so, just click it back and forth. And then I'll give it a second application. Flood it again. And it's going to drip out the bottom, and it's going to get on the board, and don't freak out. It's not going to kill anything. It's not going to harm anything. It's all just going to evaporate. This is zero residue, so that's not going to leave anything behind. But already it's stopped sticking. So I'll keep working it, and then I'll just let it sit for a few minutes just to let the alcohols and the solvents evaporate. Now that I've let it sit for a few minutes, what I'll do is I'll remove the mechanism that latches. So let's pull this out. All you got to do is pull back the spring and just lift this little piece out. Don't lose it. And what that allows you to do is it allows you to press it in and out without latching. So you can do this a little faster. And so what we're going to do is we're going to just tip this up. And I'm going to use Deoxit D100L. This is the concentrate. What you could do is you could spray in Deoxit D5, and this has 95% solvents, 5% Deoxit D100 in it. So this is a concentrated, this is a watered down version that you can spray in. You can use either one. My preference is to use the concentrate, and I just apply a little dribble onto the plunger from the back side because the contacts are on the bottom, and I put a drop on each side and then just work it. And the more you work it, the more it gets in. So I'll do this for a minute or so, and then I'll do it again and give it another shot just to make sure that it got in where it needs to be. Now, if it was easy enough to disassemble the switch, I'd probably just disassemble the switch, and then you can get in there with Q-tips and cleaners and lubricants and all kinds of things. You can do all kinds of stuff. But this works, and we just give it a good workout. And I gave it 2 treatments, so it should be all right. So let's put back the retainer. So we got it in our needle nose. Let's pull this. You don't want to pull this out right out. It's bad news if you do. Pull back the spring and just drop it back in. Let the spring hold it in place. You could put a little drop of some kind of lubricant in the latching mechanism if it's dry. Let's, for example, this. This stuff's synthetic grease. Bought it on Amazon, or not Amazon, but AliExpress. Put a really small drop down in the latching mechanism. And then when you work the switch, it'll get spread around. And that's basically all there is to it. If I really need to, you can desolder these and remove them, and they are replaceable. I'll show you here. I got brand new ones. If the switch is damaged beyond repair or cleaning, or if it's broken, or if the switch is so bad that you just can't clean it, you can always replace it These ones I prefer for small signal applications. These are gold plated contacts. This would be a drop-in replacement for this one. And these are brand new. They also come in different sizes. You can get the short ones, the long ones. You just have to order the correct ones. These are the gold. These are preferred for anywhere we have line level signals. For example, your tape monitor switches, your loudness switch, you know, any muting switches, any switch that has line level signals on it. And then for speaker switches, you would use silver plated contacts. These are silver plated. Same thing, except they have no gold and they're silver. And these would be for the, these are actually two speaker switches here. This would be a drop-in replacement for this one. And we go that way if we had to, but these switches are actually pretty good. They were just pretty sticky and dirty. So I think a good cleaning and they'll come right back. Okay, so what I want to do is I want to break this off here and end this video because this is getting long and involved and I still have a lot to do. I wanted to finish off this segment with just doing a simple power amplifier test. Just make sure we got everything good. So what I did is I hooked it all up to my bench equipment here. I got my signal generator, I got my scope, you can probably see it on the screen there. And I hooked up my AC voltmeter, my bench AC voltmeter, to measure its output. And I switched it on. And I'll show you what it did. Relay clicked on. Turn up the volume. And the protect starts kicking in. I was doing a bit of head scratching here, and I knew it had to be something I did because you know, I've been all through this thing. So I put the brakes on, I flipped it up, I checked all the connections on the bottom, I checked for DC offset on the output, everything looked good. I didn't see any broken wires, any components that were snapped off or anything that I messed up. But it was a dumb mistake on my part. What I did, when I hooked up my AC voltmeter, I had previously used my bench multimeter as a current meter. So the leads were set to the current shunt. So it was effectively placing a short circuit on the left channel. So what I did is I just removed the short and yeah, we're back in business. You can see we have full power output. I'll turn it up here and we'll get some clipping happening. See what I can do with clipping. Right about there, I think. And I'm measuring 16.97 volts RMS. You can hear the transformer doing a little bit of whining. Okay, everything's good. So what I want to do is I want to check the other channels too. I want to check the two rear channels to make sure they're working. And then I want to set it up for high power mode and let's do a power test that way. But first let's do the high power test. So I'll go in the back and I'll flip around the switch from 4 channel to 2 channel. And we'll do it again. So just stand by. And we are set up for 2 channel stereo. Let's turn this on. And here goes our protect relay. Let's turn up the volume. Wow, get quite a bit more out of this thing. Here's clipping. I'm getting 20.2 volts RMS on the output. Let me just see if I can set my probes to 10 times. Let's try that again. Okay, let's try that again. Here she comes. Clipping is right about there. 20.3 volts. Power meter is deflecting full deflection. It's almost to the 5, but balance controls are working. Bass and treble. And no scratchiness there. Everything seems normal. Okay. No heat. Let's try out the two rear amplifiers. Alright, so I switched my load to the rear channel. Let's see here. I have to set this up for 4-channel mode. Click that switch, turn this on, and we'll see my balance pots are both up. Relay clicks, and here it comes. And one channel is quite quiet. So I got clipping on the left channel. The right channel is struggling to get to clipping. I think it's that bad volume pot. So let's try it right here. Balance controls are good. I've got 16.58 on the left channel. Turn these two off. We're working on the rear channel. It shows it equal here, but you get quite an imbalance. Let's take it up. Now you got to remember, I haven't done any adjustments yet to the amplifier, so the DC balance and the bias is not set. So, but it is working good. So yeah, it's all good. I think I'm going to continue assembling and do the harness, the wire dressing, put the shields back in a lot of places that I removed, and we'll continue on. I'm going to end this one here. I think we've seen enough for 1 week, and maybe you guys are getting sick of this, but I don't know. I still have a long ways to go with this. I got all the adjustments to make and do a final test. Alright, so I'm going to leave it at that, wrap it up, and thanks for watching, and we'll see you on the next one. Take care.